Anyway, let's go here, right? So number one, we know where to put y, but we don't know what. We don't know dy dx, right? So how are we gonna do this? In order for us to do this, we have to differentiate y with respect to x, right? What would be the differential there? What would that be? Right, treat b as a function in x as well. What would be the differential of y, which is bx? What the rule are gonna use? X is x and b is a function in x. We're gonna use product rule, right? Product rule. So this is u. I don't want to use u and v because I have v here, right? But you have v and the differential of x, which is 1. We have x and the differential of v, which is dv dx. That's okay? Right? Do me a favor, just copy this first bar down, and I want to start a substitute. Like implicit. No. Implicit is very differentiating y and like you treat them y as a function. Oh, I mean like how you differentiate b here. You treat b like y. Ready? So we're going to substitute. So we're going to substitute y is equal to vx, and we're going to substitute dy dx is equal to v plus x dv dx. We're going to substitute that in equation 1. Let's call this equation 1.
What topic this is?
The same second order but different ways. Sorry, same differential equation but different way to solve. All right? If you want to call it substitution technique, you can call it that as well. So I'm going to make a substitution here, here, and here. So I'll get x by y. Y is vx by dy dx. Dy dx is v plus x dv dx is equal to x squared plus y squared. Y is this. Y is vx all squared. Right? The purpose of this is to make it much easier, right? Let's see what will happen now. When I expand this out, I'll get vx squared by v plus x dv dx. Right? Here I will end up with x squared plus v squared x squared. You okay with that? Why what? Tell me now. Next, I want to simplify this out. And you all see anything I can do to simplify it a little bit?
Yeah, do that.
What I can do? I can factor out x squared,
Yeah.
or I can divide out by x squared, right? Get rid of it. So I can divide by x squared. So I'll get v by v plus x dv dx. Remember, I divide out by x squared, right? This will be 1 plus v squared. Well, what's the next thing I can do? I can multiply everything by, I can get rid of brackets. So I could get v squared plus vx by dv dx is 1 minus v squared. What will happen to the v squareds? They will cancel. And I will end up with, writing it right here, right? I'll end up with xv dot dv dx is equal to 1. What can I do there? Check a loss here. All I did here, well, I differentiate this, right? I treat v as a function in x. I use product rule and I get this. Then I substitute dy dx here. Then right. So I substitute, and now I expand out the bracket, I expand out the bracket. And I have x squared here, x squared here, x squared here, so I divide it out. And I get here. Then I multiply the bracket out, and I get this. Then the v squared cancel, and I end up here. But I don't know what to do when I reach here. What I can do when I reach here? Huh? How? Close. What the technique I could use here to integrate this? Separation of variables. Right? I could use something called separation of variables. Can you not hear? So you're doing it all work. I like that. Carry across dx and carry across dx. Is this much easier to integrate now? Can I integrate this easily now? Integrate, integrate. What's the integral of this? What's the integral of this? V squared on 2. What's the integral of this? Ln x. Right? And I know what v is. V is y on x, right? Since v is equal to y on x, I'll end up with y squared on x squared. And I flip over 2 is equal to ln x plus c. I can multiply everything by 2x squared. And I will get 2x squared ln x plus 2x squared by c. Are you okay with that? Daniela? Right? So the objective is to reach here. The objective is to make that much simpler to integrate. All right? Copy it down. Let's try next one. Yeah. Ready? Thomas, move. I'll be here moving. Are you ready? All okay now? So all you're doing, differentiating, substituting, simplifying. If you end up at a point where it's not much easier to integrate somewhere else, right? You probably simplify somewhere else. But okay? So you're only using this technique when? You will only use this technique when they give you what? A substitution. Right? Well, if they give you this, you'll have to follow this method out. So it's not choice. If they give you substitution, no other method will work. Yeah. I will stop from there. You didn't know you guys to attack online? No, I was not. Try this one now, please.
Here, drop in. Apply. Down.
I take up the answer question, right? We get two right today now. Take up. Go for two in a row now. Nah, too much. Oh yeah, so that's for quick finish already? Oh. That's it. That's it. Go up. Or do you want to give it one? So after you solve it in terms of being just substitute that, but yeah. And you're done? Oh yeah. Yeah, go without that. ทำไมยังไงนี้When you know how you can see like champion thing, you do what? Quanto vuoi sia full champ. แต่วันนี้เดี๋ยวก็ได้ให้เราดูว่าถือว่าช่างของที่เอา like no not if I do have the time when it to have the replay on cable. I know what I way to watch it. Well, shot it going on now. I can't watch it live shot. And it's me. All right, so we know what dy dx is, right? Dy dx is the same thing, vx dv dx. So then we're gonna make our substitutions, and you'll get x plus vx dy dx is equal to x minus, sorry, I forgot to substitute dy dx. Am I right? What? No, it's 4-3. 4. I just imposed it. What? You'll have that? What's the next step? Yeah, forget that. Forget that. All we can do is expand brackets, right? We could probably expand the brackets out. Wanna do that? Expand the brackets out, x by v, vx, x by this, x squared dv dx, vx by this, v squared x, this by this, vx squared dv dx is equal to x minus vx.
Let's do that X.
Huh? Divide everything by x.
Yeah.
So we can divide everything by x, so we'll get v plus x dv dx plus v squared plus vx dv dx is equal to 1 minus v. And then canceling off,
So,
right? So probably we could just see what will happen if you bring the like terms together. Yeah? Yeah, Faith? Where's we do Faith? We can leave it as so. So we'll have x. Try it. I'll give it a minute. Try it. The objective is really to make it simple, all right? Two. Solve. I stick. You can separate variables now. So you put on that side. You have all these here. And you have this p and this p here. Put on that side. Bring the like terms together. So here you have x dv dx. In your mind, right? You should be thinking of how you can solve it. Right? You have x dv dx plus vx dv dx. We don't want this here, so we put in this here. We don't want this here. Right? So I just bring the like terms together. Anybody get it? Then probably all we probably do is separate variables and do our one. Possible? No, that's not true.
so about yeah.
right? So I mean, the objective is to get
So if they're like fuck there, like put out in brackets, yeah.
yeah,
And
you do something like that.
yeah,
Then what? Flip this here.
yeah,
So we'll get x dvdx is 1 minus 2b minus b squared all over 1 plus b.
yeah.
So we have all the b's on one side now. Yeah. So what we can do now? We have all the b's here. We have x here. We can probably separate the variables now. Yeah. So we can separate the variables, right? So I'm bringing the b on this side, but if I bring this on this side, what will happen to the fraction? It'll flip over, right? So I'll end up with 1 plus b all over 1 minus 2b minus b squared. Is equal to, and I'm flipping the x on this side, dot tx dot tb. Right? So when I flip this here and I flip the x there, it will look something like that. The right hand side should be easy to integrate, right? But look closely at the left hand side. Can we integrate that? Watch it good. Whenever it's a fraction, what are the options we have?
So,
Huh?
and you have to do it because no, they're on top of something, but already something.
So what are you thinking of doing? Partial fractions and break it up?
Yeah,
But before we do that, we have a fraction already. We can integrate it normal way. Can I integrate this normal way? Bring it up and integrate it? No, because this is to the power of 1. Well, it'll be minus 1 when it moves up. So, what you check after that? What you do? No, that's if you want to convert to partial. We don't want to break it up into partial. What else we could check? What's the next way to integrate a fraction?
lots.
Ln, right? So check and see if the denominator, if you differentiate the denominator, if you'll get a numerator. We bring out the 2. You'll realize that? What's the differential of this? Minus 2 minus 2b. So, enter 1 that here. So, enter 1 minus 2 here. So, I have to divide by minus a half. Right, remember that? So, technically, I could use ln. And I will end up with what? Minus a half ln of this denominator is equal to ln x. Huh? Which one? So the integral. So you remember this? If you have f of x underneath here, and the numerator is f prime x, the integral of something like this is ln f of x. Yeah. So if underneath here is, let's say, x squared, and on top here is x, the differential of x squared is 2x, right? So if you want to put a 2 there and you divide it out here, so you cancel. And the integral of this is ln x squared. Then you include the half. Right? Draw all this. It's on the video. You can watch. I don't want to put about the video. All these videos sorted out earlier. All public now, right? Marquis and somebody here. On YouTube, the public, and if you have their last video. Do you want to say anything some people? Yes, all of this. I think you could have a link on the no, 1 plus c, no matter. If you write plus C here and I write plus C here, and I add them up,
Yeah, big C.
you get big C. So I technically big C. So no, it will be two different constants. Here might be 3 and here might be 4. And I bring them together, you'll get a new constant. So same concept. Oh wait, I forgot to put back in X and Y. So you'll get minus a half ln of 1 minus 2 by y on x by y on x squared is equal to ln x plus c. If you want to make it look a little thing, you can multiply everything by 2, bring it up, cancel off the ln something, right? But like that, good enough for now.
I don't get it.
Hmm?
I don't get it.
Yeah, up to there. The first one. I want to try a second order.
This is the second one.
But this first order. Second order time. Same process, just a longer. Right? Because watch. Right? Although it never came before, the substitution could lead to separation of variables, or the substitution could lead to what in a technique we learned. Integrating factor. So we can end up at a point where we have to use integrating factor.
You see what I do? Yeah, I'm not doing this out. You want to do it? I'm cashy.
Ready? How much mark? Oh, I like 15 marks. 15 marks. It came once here, 27. You never came. 2 marks and 13 marks. Easy. Well, yes. One like this. It came once and that's second order. What's the trial solution for string? What's the trial solution for strings? What's the trial solution for alphabetical string? That was lambda sin x plus beta, right? All right. Let's see if we can do it a little bit long. Let's do the one in the past paper first. Remember, the point of the substitution is to take you to a point where you could solve it. The point of this substitution is to turn this into a point where you can apply separation of variables. The one I given you here is just to take you to be able to find the complementary function particularly. All right, same process. All right, so let's take a look at 2017, number 6, part 2. Right, it's kind of long, so you might get to do our next one now. 23, I mean, 15 marks for this. It might take a while. If you finish it, I'll give you an extra. Actually, we even go to this, so I feel it might be an extra. You actually doing some work. I feel the problem. I think I know the problem. Well, I think it's a problem.
This?
Yeah, you know, here I'm getting real work done. Cool. That is not obvious. That's fine. You online? You online? Chinese online? I didn't see him.
Sir. What kind of thing is that?
When the real doing the work, boy.
Well, I feel I had to stay online from now on then.
I see that work, check up you. First time it's in phone call. All right, what you saying? 15 marks, right? Well, like you say, it does do me much. Oh, but wait now.
50 plus 50.
That was. Sit 30 plus 2. Right? Look at it, right? That's second order. They give you right? They gave you as what? No, u is equal to what?
By prime.
Y prime, right? And then they give you an equation, y double prime is that can be reduced. Eventually you didn't have to, because you could solve the one on top.
And you prime of that.
Right? So u prime, sorry. So u is equal to y prime. And everybody can tell me what is u prime?
U prime is
Anybody else?
cos 3x
No.
minus cosine 3x minus.
Right? So all you really have to do there is substitute u and u prime. But to be honest, this second order will solve without making a substitution. Because it's kind of simple, like. Anyway, maybe some substitution and then solve it here. You solve with the u part, like long.
When chicks come up, bro. Sounds like you do this one, yeah. That's okay. I know. This one, yeah, the one, because I got they don't have to listen. Right. You got that with them. I like that. Yeah. I don't just was.
Yeah, should we take now? Wait, you gave ready for another job? Hey, but he wants to look lower. Hey, wait for. Yeah, we will. Yes. Oh. Yeah. I'll not be necessary. Yeah, we're gonna show you the spectacle. All right, let's check this. It's a little bit long, it's like a normal question. Jaden, you can't do it? Jaden, start it now, please. We're not too much trouble. Repeat it just like the one from last week. Just watch back the trick from last week. Huh? Part one is just one line. Pam, 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 pam.
No, pera, isso é legal. You like it, too. You like anybody.
Marky, shut up now, eh?
I'm telling you, guys, racist.
That's the man's business.
Not you racist. Well, it's 2025.
Yeah.
So, okay, yeah.
I know, they have to type up. I didn't want to sound near the same. Huh? Someone loud.
Wait, what is Indian accent?
Alright, so watch here. So your first step, right? So if u is equal to y prime, what's u prime? Y double prime. So all I have to do is substitute here. So if I substitute in here, I will get u prime minus 4, sorry, plus 4 y prime is u is equal to 2 cos 3x minus 4 sine 3x.
Alright, then.
Huh?
Yeah.
Well, that's why to prove this. No, to be honest, there was a limit, but we just doing what the classic was thing.
Alright.
It was technically a lame one. Right? So, like normal. Right? Actually, this is a what? It's a first order. So which technique we gonna use? No, which first order technique we gonna use? Which big one? Right, no, I was trying to use a second order, but do I do a second order because it's a first order? So we could use this dy dx plus what letter I had yet? P, right? Py is equal to q of x. So we're going to use the integrating factor. We have q of x here, and this is p. So we're going to another while, so we go try it now. Yeah. It doesn't matter. I just need it. I'll have to go with that. The function to the value of the stuff. Huh? Why will I will F and G?
Yeah.
Yeah, well, it don't matter. Same thing, right? So in this case, we're using I. I is what? I is what? I is e to the integral of p. P is 4. So that's 4 dx. So that's e. What's the integral of 4? 4x. That's okay? What do I do now? Solution is what? So the general solution is always what? Check back and see so you have an idea what's going on. It's y by what? y by I is equal to the integral of q by I, right? Right, well, I using q. So that'll be y by e to the 4x is equal to the integral of e to the 4x multiplied by 2 cos 3x. This thing really low. So we had to multiply this out, right? Anybody recognize what we had to do? I just multiply it out for you. Anybody recognize what we had to do? Now reduction formula. Integration by parts. Here with our law. Right? So you see why 13 marks? So we have to do integration by parts on both sides. This one though, get to work hard for that formula. I mean, it's it. You have to do integration by parts here. Work that out. And integration by parts here. Yeah, go to. Oh yeah. Integration by part. Yeah. By part 5.
Yeah, I understand. Yeah, but-
Right, you're done? No, I just squeezing dx and 4, sorry. Right, so let me just at least do one part and you'll finish it up. Right, so remember integration by parts like this. What do we do? Right, does it matter which one we choose as u? And then we choose one as dv, right? It don't really matter which one you choose, right? Just stick with it. Right, stay consistent with the one that you choose. So this will be 2e to the 4, sorry. This will be 4e to the 2x. dv dx here is what? dv dx here will be the integral of this is 1 over 3 sine 3x. The integral of cos is 1/3, right? Integral of cos is sine here. Now substitute it back. You'll end up with 1/3 e to the 4x dot sine 3x minus du by this. So I got 4 and 3 by the integral of e to the 4x dot sine 3x. What's the next step? Parts again here, right? I'll remember that? Even if you don't remember, right? Parts again here. And do not change it. If it choose u as the e, stick with that. And dv here is sine 3x. So du is equal to 4 to the 4x. The integral of this will be minus 1/3 cos 3x. Now we'll end up with the integral of e to the 4x dot cos 3x dot dx is equal to this 1/3 e to the 4x dot sine 3x minus 4 and 3 by, I'm gonna integrate this now, u by v minus 1/3 e to the 4x cos 3x minus the integral of this by this. So that'll be 4, this by this, sorry. That'll be plus 4 and 3 e to the 4x dot cos 3x dot dx. Anybody remember what to do now? Right, multiply it out, carry it across. Right, so that's only one term we do. You gotta come and do this term here after. Right, so that's 13 marks that easy by the law. Online I write now a little bit smaller because I want to fit the whole thing, right? Anybody see what's going to happen with all the e to the 4x later on? Right, they're going to unpack out because you have that here. They're going to cancel off and you see something nice, right? So that's the exciting part coming up soon. Right, so in case you get lost, I'm moving all the integrals on one side. So now I have in 1 by e to the 4x dot cos 3x dot dx plus 16 on 9 integral e to the 4x dot cos 3x is equal to this 1/3 e to the 4x right. So this is 16 on 9 plus 1. How much is that? Huh? 25 on 9. That's yes. He was paying attention.
Yes.
Right? And then after divide out by 25 on 9. What you get? 3 on 25. Huh?
Yeah.
Right, 3 years later, is what we have. Now in the part for you here, Adelia, I did part alone here for you. The next part is for you to come and do, right? Yeah, I already did this. You have this to come and do now. Right? So I found the integral of this here, the part in greens.
What's that integration? Say.
Pardon me, sir. So this is equal to this, sir. So I could take off this and I could write this, sir.
Oh.
But I only part of it. Now you have to work out this. Anytime? I was right, it's really gonna take a little time to finish all this. Excuse me, if we're not done, you have to do this part. Oh yeah. Y'all think, just take a little glance here. Y'all think that we could just write the answer by watching this?
Yeah.
Right? Everything with sign will now be, and put your signs, right? Watch your signs. Anyway, homework finish that up.
Really?
Yeah. Yeah, because that next piece I know was space here.
Yeah, it's not right.
Right? So homework, get the next part, add them up. Wait. You're not done when you do that. Just put them together and then divide by this. Right?
What?
I find we should just do this, I don't want to make us do all that. Yeah. So your homework finish that up. Right? We'll take a break for 2 weeks and then we start. And then in the holidays we do matrices and probabilities. Starting back the first Wednesday. In January, I mean? December the 1st, I don't know, take the timetable now. Yeah, the group.